Find the least number greater than 1 which leaves remainder 1 when divided by 21 or 28 or 35. Now, let's understand this first. Okay, forget the remainder 1 wala part. Let's first find out the least number which is divisible by 21, 28 or 35. Okay, so a number which is divisible by 21, 28 or 35 is going to be a common multiple of these three. And since you want the least number, you want the least common multiple, right? So we'll basically figure out the LCM of 21, 28 and 35. Now we know that LCM is nothing but common into uncommon factor. So between these three, the common factor is 7. Okay, 21 क्या होता है? 7 threes are, 28 है होता है 7 fours are, 35 is 7 fives are. So uncommon factors are 3, 4 and 5. Like, so you can multiply these. Okay, 7, 3, 21, 4, 5 are 20, 21 times 20 is 420. So 420 is the least number which is divisible by 21, 28 or 35. Okay, now we look at the condition given in the question that you want that the least number which leaves remainder 1. If you divide this number 420 with 21, 28 or 35, okay, you will simply get the remainder 0. Why? Because this number is the common multiple of 21, 28 or 35. So what do we do? To ensure that you get remainder 1 when you divide this by 21, 28 or 35, we simply add a 1 to this number plus 1. Okay, so the required answer for this question is 421. The same thing can be basically summarized by the law which I have displayed on the screen at the bottom. The general form of the number that leaves remainder R, okay, when divided by A, B or C, okay, that general form will be LCM of A, B and C का कोई भी multiple plus the common remainder. Okay, so by that logic, okay, any multiple of 420, okay, 420k, any multiple of 420k plus 1 will satisfy the given condition. Means you divide 420k plus 1, okay, you divide this number with 21, 28 or 35, the remainder will always be equal to 1 irrespective of the value of k. So if k is equal to 1, you get the smallest number 421, right? The next higher number will be 420 into 2, 840 plus 1, 841. So 841 also is a possible number which when divided by 21, 28, 35, you will give remainder 1. Okay, 420 into 3, 326, 3, 4, 12, 1261. This will also give you remainder 1 when divided by 21, 28, 35. Okay, this is the LCA model 1. Okay, find the least number which leaves remainder 1 when divided by 2, remainder 2 when divided by 3, and remainder 3 when divided by 4. Least number which leaves remainder 1 when divided by 2. Number which when divided by the number 2 leaves remainder 1. Ye tab hoga when the number is odd. Makes sense, right? Because every even number will be divisible by 2 itself. Okay, so I'll list first all the odd numbers. Okay, starting with 1. Okay, so on and so forth. This is how the list will go. Now you want that the number should leave remainder 2 when divided by 3. So in this same lot of numbers which I have written, okay, we will try to divide all these numbers with 3 and check the possible remainder. So 1 on dividing with 3 will give you remainder equal to 1 because 1 chota hai 3 se. Nahi chahiye. 3 on dividing with 3 gives you remainder 0. Not required. 5 on dividing with 3 will give you remainder 2. 3 ones are 3, 2 niche aa gaya. Right? Ye chalega, ye chahiye. Right? So 5 is something which you'll be interested in. Same problem is with 7. If you divide 7 with 3, the remainder is 1. Not required. If you divide 9 with 3, the remainder is 0. Multiple of 3, not required. If you divide 11 with 3, the remainder is 2. 3 is 9. 2 carry ho gaya. Yeah, so this is what we'll be interested in, 11. Right? So basically now I can make a new list. 5, 11, 17, 23. All these are the numbers which on dividing with 3 will give me remainder equals to 2. Okay. Second condition also met. Third condition is it should be giving you remainder 3 when divided by 4. जो अपना ये last condition in the question. Remainder 3 when divided by 4. Right. So again we'll check in the new list we have obtained. 5 on dividing with 4 gives you remainder 1. नहीं चलेगा. Okay, 11 on dividing with 4 gives you remainder 3. Yes, 4 2s are 8. The remainder is 3. Yes. So this is the required answer. Okay, the least number pucha hai, right? So the least number here we got is 11 and hence your answer is 11. Okay. Okay, 17 of course will not satisfy the given condition. 17 on dividing with 4 gives you remainder 1. 4 4 the 16 remainder is 1. Okay. 23 के बारे में अगर बात करें 23 dividing with 4 4 5 is 20 the remainder is 3. Yes. Okay. So the next number is 23. So what do you observe? We have a pattern being formed, right? The least number of this category is 11 as we found. The next number is 23. दोनों में gap कितना है? 12, right? Okay, so the next number will be how much? 23 plus 12, 35. So if you observe carefully, all these numbers are basically multiples of 12 minus 1, right? 11 is 12 minus 1. 23 is what? 24 minus 1. 24 is 12 into 2 minus 1. 35 is what? 12 into 3 minus 1. So on and so forth. Okay, the general form of the number, okay, that leaves remainders x, y, and z when divided by a, b, and c such that their difference, okay, a ka difference with its remainder x, b ka difference with its remainder y, and c ka difference with its remainder z, okay, all these differences are equal, and that's equal to r. So general form of this number will be LCM of the divisors ka koi bhi multiple minus the common difference r. Okay, this is exactly what we call as the LCM model 2. And let's see, we go on to the next part now. We try to find out the LCM model 3. Find the smallest number greater than its divisors, which when divided by 9 and 11, leaving remainders 5 and 2 respectively. Okay, so basically एक number है जिसको 9 से divide किया तो remainder 5 आता है, 11 से divide किया तो remainder 2 आता है. Okay, यहाँ पे ना तो remainder equal है. Okay, the remainders are not same, they're not equal, and also the difference of the divisor and the remainder, they are also not equal. Okay, so we have a slight problem here. This is the LCM model 3. Okay, it's a very general method to solve these questions. We'll see now. We know that when you divide the number by 9, the remainder is 5. So can I say the number is of the form 9 ka koi bhi multiple plus 5, right? Okay. Similarly, when you divide the number by 11, the remainder which you obtain is 2. That means the number should be of the form 11m plus 2, any multiple of 11 plus 2. Okay. And then we start by equating them. The same number, right? Okay. Now, what you can do is you can take the lesser number, chota number hoga yahan pe. Between 5 and 2, the smaller number is 2. You take 2 on the left hand side. You will get 9k plus 3 should be 11m. Okay, now finding out suitable values of k and m, okay, we will be able to find out the requisite number. Okay, we have to basically find out a number, okay, which is of the form 9k plus 3 and also a multiple of 11. All right, so what you can simply do is you can try to find out a multiple of 11. Okay, a multiple of 11 which is 3 more than a multiple of 9. Okay, so which we can see 11, 22. 11 minus 3 is 8, 22 minus 3 is 19, multiples of 9 hai nahi. 33 minus 3 is 30, 44 minus 3 is 41, 55 minus 3 is 52, 66 minus 3 is 63 million, right? Okay, so basically this is 11 into 6 giving you 66. And on the left hand side, it is 9 into 7, 63 plus 3, again giving you 66. Trying to analyze the values of k and m जो हमने अभी निकाला है, k का value 7 आया है and m का value 6 आया है. Okay, so we resubstitute them in the equation here. Put k is equal to 7 or you put m is equal to 6, you get the smallest number. Okay, 9, 7, the 63 plus 5, 68. 11, 6, the 66 plus 2, 68. So the smallest number required in the answer is 68. Okay, and that's exactly what you mean by the LCM model 3, and that is the general form of the number that leaves remainders x and y when divided by a and b can be found as a ka multiple plus x, b ka multiple plus y, and you equate them. Okay, this is also called as the Chinese remainder theorem, guys.